Decision support and automation sit on a spectrum shaped by risk, speed, and oversight. Decision support equips humans with context, explanations, and ranked options, which fits high-stakes or ambiguous situations. Automation executes policies consistently and fast, which suits repetitive or time-critical tasks. Consider fraud review. Analytics can flag suspicious transactions with scores and reasons for an analyst to review, while AI can automatically block clear-cut cases under a defined threshold. A trap is to automate before you trust your inputs or thresholds, which can amplify errors. A practical approach is to start with decision support, measure accuracy and impact, then phase in automation where confidence is high and rollback is easy, keeping humans in the loop for edge cases. Data readiness and feature engineering determine how far either approach can go. Readiness means your data is complete, timely, and consistent, with clear definitions and owners. Feature engineering transforms raw inputs into meaningful signals, ranges, ratios, lags, or encoded categories that models or analyses can use. Picture a shipping dataset where raw timestamps become transit durations by lane and season. That single transformation can unlock better planning. A common misconception is that more data always beats better features. In reality, tidy, relevant features often outperform raw volume. To apply this, map each metric or feature to a business question, document assumptions, and track drift over time so your inputs stay aligned with reality as processes and behavior change. Explainability builds stakeholder trust by showing how results arise and how confident the system is. For analytics, explainability might be clear formulas, transparent filters, or sensitivity analyses that show which inputs drive outcomes. For AI, it may include feature importance, example-based reasoning, or policy constraints that reveal why an action was taken. Picture a credit decision tool that highlights income stability and payment history as the main drivers, along with a confidence band. The misconception is that explainability and performance always conflict. Often, careful model choice and documentation reconcile both. To apply this, provide plain language rationales, show uncertainty, and preserve an audit trail so reviewers can reproduce findings and leaders can defend decisions responsibly. Risk management covers bias, drift, and misuse before they cause harm. Bias enters through unrepresentative data or proxies that encode unfair patterns. Drift occurs when real-world behavior changes and models lose accuracy. Misuse happens when outputs get applied beyond their intended scope. Consider a hiring screen trained on past data that underrepresents qualified groups. Without checks, it may perpetuate inequity. Detecting bias requires diverse test sets and fairness metrics. Detecting drift requires monitoring input distributions and outcome accuracy over time. Clear usage policies prevent outputs from being repurposed in contexts they cannot support. Treat these risks as operational duties with owners, alerts, and escalation steps, not as occasional compliance exercises. Cost, skills, and time to value should anchor technology choices. Analytics often delivers quick wins with existing skills and tools, while advanced AI may require specialized talent, labeling efforts, and platform investments. Imagine a service team debating a chatbot. A carefully designed knowledge search may solve 90% of needs today, while a conversational agent requires more runway. A misconception is that higher sophistication always yields higher returns. In reality, overhead can erase gains. A practical approach is to estimate build and run costs, factor in training and maintenance, and weigh opportunity cost. Pick approaches that reach reliable outcomes soon, then reinvest savings into selective, higher leverage capabilities. Choosing the lightest viable solution keeps projects focused and resilient. Start with the simplest method that meets accuracy and speed targets, measured impact, and only scale complexity when evidence demands it. For example, a rule-based alert on late shipments may outperform a complex model if the root cause is straightforward. Light solutions are easier to explain, maintain, and govern, which matters when teams change or priorities shift. The misconception is that simplicity signals a lack of ambition. In practice, it signals discipline. Define viable with clear thresholds, agree on decision rights, and set review intervals so the solution evolves with business needs rather than calcifying. There are moments when rules decisively beat models. If the domain is stable, the data is sparse, or the policy is mandated, explicit rules provide clarity, speed, and auditability. Think of legal age checks, safety interlocks, or cutoff thresholds tied to regulation. Rules also serve as guardrails around models, bounding actions and preventing out-of-scope behavior. A trap is keeping brittle rules where patterns change rapidly. Here, models may adapt better. A practical pattern is to codify hard constraints as rules, let models optimize within those bounds, and keep a human override pathway for exceptions, preserving both control and agility. Collaboration among analysts, data scientists, and engineers turns ideas into dependable systems. Analysts frame questions, define metrics, and validate usefulness. Data scientists design features, select methods, and quantify uncertainty. Engineers build pipelines, deploy services, and ensure reliability at scale. Picture a churn initiative where analysts define save offers, scientists predict risk windows, and engineers deliver real-time triggers to a customer platform. A misconception is that any one role can do it all quickly. In practice, handoffs and shared standards make the outcome sustainable. Establish shared glossaries, version control, and runbooks so work moves smoothly from exploration to production without losing context or quality. Communicating limits and monitoring in production keep solutions honest over time. Limits include ranges where predictions are reliable, cases where confidence is low, and scenarios that require human review. Production monitoring tracks input drift, output stability, latency, and error rates with alerts and rollback plans. Consider a demand forecast that degrades during a supply shock. Monitoring surfaces the drop in accuracy, and a runbook switches to a simpler baseline temporarily. A misconception is that launch equals success. In reality, day 2 is where reliability is earned. Pair every deployment with a measurement plan, a safe rollback, and an owner accountable for quality. Choose the approach by the outcome you seek and the accountability you can uphold. If the goal is shared understanding and human judgment, analytics is the most direct path. If the goal is rapid, consistent action at scale within clear boundaries, AI can deliver automation with care. Often, the best systems blend them. Analytics to align people on the story, AI to carry out well-defined steps, and governance to connect insight to responsibility. When you match method to mission, document assumptions, and keep eyes on performance, you build solutions that are not only powerful but also trustworthy, adaptable, and worthy of the decisions they inform. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.